In my last video, we finished the pin cycler and got everything ready for today's video where we build the pin setter. I'll be showing you guys how I make my pin setter and how you can make your own if you want to. Before we do so, let's finish building up these walls and get everything prepped for the pin setter. To do that, I needed more pieces, and luckily they arrived just in time. To start this episode off, we'll begin building the pin distributor, and then we can move on to the pin setter that goes up and down, and lastly, the pin rack. Now, we got the walls up. So next, we need to make this chain be able to go here, so that way we can shift it side to side. Doing this will allow us to take a pin from here and put it in the spot that it needs to be on the lane. If we make the carriage that carries the pin around a conveyor belt with two cogs attached to that frame, then we can hold the pin until we spin the conveyor belt. That will then move the pin and let it drop into position. So, we mount it onto here. We can then have it be able to slide side to side and forwards and back. Having a gear connected to that, sat in here. Now, when we move this, that gear spins. If we hold this and spin the gear, that would move the carriage. Putting that gear onto a mount that would hold the treads would allow it to go forwards and backwards, and then if we put rails on the bottom of that carriage, it would allow us to move it side to side. And we're done. So now we can move this side to side, forwards and backwards, and spin the conveyor belt. Now we can take that pin, drop it there, and it goes onto the track. A current issue is that once this thing moves the track out far enough, it begins to want to tip. So let's install something over here and a rail from side to side, that way it can't tip. As well as the railings that just go on the top so that way it can't lift up, there's also one in the front that prevents it from kind of tipping forwards with that gray beam and these plates that are holding it back. So now, when we pull this forward, it doesn't tip. Now that we have this be able to move forwards and backwards, left and right, as well as be able to spin, let's attach some motors. Then we'll begin building the second section of the pin setter. Now we have a motor up here attached to a slip gear. That way I can still move this around while we're testing or if it jams. But when we spin the motor, it still moves it. The actual treads are also now motorized by a motor on the back. So now, with a Lego EV3 brick, now we can motorize a few things. Right now I just have two cables connected. I can plug them into any motor. Here we can see it moved this forwards and backwards. And let's see the tread move. Currently they're all set to full speed. We'll slow them down with the actual program, but this gives us a good idea. Here are three major tips that I was having struggles with. The first one is that you want your point to where the motor moves your carriage to not be too far away from your rails. Ideally it'd be in the center, but mine is just outside, and as we can see here, it can move just fine. Secondly, you want to make sure that your gear is clamped down with some sort of bracket system, that way it can't go up and allow the gear racks to slip. And finally, you just need to make sure that your treads are fairly flat. Mine go down and up just a little bit, but I installed a rail underneath, that way they stay pretty flat. As we saw earlier, pins sometimes fall down with a little bit too much speed. Let's see if we can add some sort of lip or gate or curtain to slow them down. Through a lot of testing, I finally found something that works. Now when the pins fall down, they either get caught on the lip of the treads or they get slowed down by that flap. But when the treads move, it still allows them to pass underneath just fine. If we take bowling pins and arrange them on a grid, I would like mine to be 2 studs apart. So I need to make a frame that can hold them all in that area. Upon finishing building this pyramid, I realized that there's an issue. While the distance between the pins from side to side is 2 studs, the distance between the pins front and back in the diagonal direction is more than 2 studs. So let's see if we can get around this by building in different ways. The first idea was using jumper plates in the forwards and backwards direction. That makes that way 1.5 studs, which makes a diagonal roughly 2 studs. Unfortunately, this wasn't very practical, so I had a better idea. Instead of building like that, let's try building sideways. But unfortunately, another problem occurred. I need 2 studs in that forwards and backwards direction, that way I can run 2 axles next to each other. Those axles are the ones that control the flippers that are able to pick up the pins. I may revisit this idea later, but for now, we're going to go back to the original idea of that pyramid. For the flippers that lift up the pins, I decided to use rubber elements. That way, they may be able to grip the pins a little better and have a little give to them. So, each hole that would have a pin has 2 flippers, one on each side, and each row is connected. Later, we'll add gears and chains, that way we can flip them all at once, but for now, if we flip these 2, it'll be able to pick up this pin. Now, let's finish building this up. Now we need to build another frame, but this one's gonna have bars like those that can hold the pins on their backs until they lift up, then it'll drop the pins into the frame we just built. I think before I build anything else, let's build the second section of the machine. This section will contain the Pinsetter. So let's start by building these walls up, that way we have something to mount the Pinsetter on. I'm using Technic elements here, that way it can be modular, so if I run axles through there, it'll lock them together. As mentioned earlier, we also need a secondary frame that's able to hold the pins until all 10 of them are there, that way they can then be dropped into the Pinsetter. These 2 beams and that third one that sticks across should do the trick. They're able to hold the pin in place until they lift up, then they drop the pin down. If we make something like that and attach it together for all 10 pins, we'll be able to have another frame that's able to store the pins while it gets them ready. If we build up the walls of the machine just a little bit more, we'll be able to mount that in there. With the walls up and this mounted on, now we can see that the pins would be able to fall off of there and into here. I'm currently unsure of how they're actually going to do that though. I cannot imagine it's going to land perfectly in there every time. And as I'm sure you guys can imagine, it does not. So I added some ramps, that way it will funnel into the hole. Once all 10 pins would be in there, it's able to release them into the Pinsetter. I also had to extend out how far the track goes, so I added these 2 arms to prevent it from sagging too far. Up next, let's motorize that. We can attach a motor to any of the joints here. If we put one on the back corner, it likes to bend. If we put one on the back middle, then the back corners don't get the pressure. But if we put a motor on the very front, it's able to evenly distribute the pressure onto all 10 of them. So I started working on the mechanism, and it's not exactly going well. Having this rod just connected to that and attempting to have it pull, it works, but the torque on the actual motor is so high as it pivots down here. I think instead we're going to try something else. So I got a motor attached and that linear actuator as well. So if we power this motor, we can see that in there begins extending, but it's pretty slow. I decided that mechanism just isn't going to work. So after what seemed like an hour of digging through my bins, I found enough of the frictionless pins to make sure that slides without friction. Now with just a simple push, it's able to rotate back and forth. If we connect an arm over here, attach it to the motor, now when we spin the motor, it's able to rotate it. Now let's attach the Pinsetter that moves up and down. Rubber flippers were added so that way that it can pick up the pins, but if we hold those in the closed position while it goes down, it would be able to land on the pins and detect that there's one there. We can use something like this plunger system, which raises up when it hits a pin, but if there's not a pin there, it would stay down and we'd be able to sense that. Like the Pinsetter itself, this went through several iterations, and here's a sped up version. I first tried these red bars, and then the fishing line I just showed, but the fishing line let it sway too much and the red bars seemed to go up too high, so I eventually made a more compact version of those red bars and I ditched the fishing line. Here, those bars are connected in 3 points, and we also have the mechanism that would be able to detect if there's a pin there. Next, we need to motorize the flippers and be able to chain up the 3 gears for each of the lift points. That way we can move that frame up and down. Starting off with the gears that are attached to the flippers, we're adding the gears to the axles that are right next to each other and then the chains to group those together. So now if we spin this axle here, all of them will shift. Now that that's done, we're able to put it back into the machine and begin motorizing it. With the Pinsetter back in the machine, let's add those gears and get this thing motorized. This took quite a bit of time, but eventually I got all the gears connected and we're able to turn it. Lastly, let's just attach a sensor that's able to detect if the Pinsetter is hitting a pin. That's the movement we need to detect, and originally I was going to use either a button or a color sensor or something and possibly attach it to all 3 points, but then I realized that if it hits anywhere on there, it changes the degree that sits at. So if we use a gyro sensor like this one here, it's able to detect the angle that it was at compared to the angle that it's now at. So if we attach it anywhere on here, it'll be able to realize that it's hitting a pin. Today was a big episode, and hopefully it helps you if you wanted to build a Pinsetter of your own. If you have any questions or want more details in any of the parts, be sure to leave a comment and ask about it. In my next episode, we'll attach a motor onto the Pinsetter to move it up and down, as well as do the pin sweep, the gutter, the lane, all of those big things. So be sure to subscribe as it's always free, and that way you don't miss the next video.